Hello everyone, welcome back. In this video, we are going to focus on a different type of machine learning. So far, we've mainly focused on regression, where we are trying to predict a target value that is a real number, or classification, where we're trying to predict a target number, which might be something that's not a real number, like survived or didn't survive. And in this example, those are both examples of supervised learning because you're trying to predict a target given a bunch of examples of a data point and what the target was. Clustering is a different type of machine learning where typically what you're given is you're just given a bunch of points and you want to split these points up into groups. There's no targets, just a bunch of points. In particular, if you click this link right here, then up pops this picture. You need to scroll down just a little bit. But what we can see is we have a bunch of data points and we want to separate them out into groups. There's no labels. We just want to split them up into meaningful groups. So what we're going to do is we're going to start by recreating the picture from scratch. We're going to need kind of our standard imports. Pandas, NumPy, and PyPlot. And now we're going to try to create a bunch of points that are kind of blobbed together like we saw in the other picture. And so to do this, we're going to use the aptly named makeBlobs function from the scikit-learn.datasets module. So the result of makeBlobs is actually a little bit counterintuitive because I just told you there are no labels. So our data points are going to be X, and it's going to be a number of samples by 2 NP array, NumPy array. And the columns are going to be the X and the Y coordinates, and the row is going to be the point number. Y true is going to be the labels. And this is where I was, this is what might be a little bit counterintuitive. I just told you there are no labels. However, this is a synthetic example for teaching purposes, so we're going to give you some labels. We're just not going to use them. We're going to make the number of samples be equal to 300. The number of centers equal to 4. We're going to make the standard deviation within each cluster to be equal to 0.6. And we're going to use the random state set equal to 0, so that way you get exactly the same results that I do. And now let's take a look. Fig x equals plt.subplots 1 x.scatter, and then we're going to do x column 0 against x column 1. Okay, and so now we got a plot that looks basically the same as the plot on the that we saw before. And in particular, we can see that there's clearly 4 groups that we'd want to split things up into. Now, the question is, if we can see the groups, why do we need to do machine learning? We can see the answer. And this is where, again, I want to point out that this is a toy example meant to illustrate. And one of the things that's not really realistic about this example is that we're in 2 dimensions. A real-world application of this might be, say you're a company and you want to divide your customers up into different groups. This is something called market segmentation. And you might know a ton of different things about each customer. So for each customer, you might have a list of 10 numbers rather than a list of 2 numbers. So then what you would have to do is you have to plot the customers on 10-dimensional space. And unless you are significantly better at this than I am, you are not able to visualize things in 10-dimensional space as easily as you are in 2. And so what we're going to do here is we're going to develop a systematic machine learning-based approach, which can then be applied even to this more realistic high-dimensional data. So to do this, we need to import the k-means cluster and see how we do. So it's clustering, so the module is going to be sklearn.cluster, and we're going to import the function, which is named k-means. K is the number of clusters. K-means is going to be equal to k-means with the number of clusters equal to 4. And then we're going to fit this to our data. And then we're going to use this to try to make predictions. K-means.predict. Use the predict method. And what we see is that the k-means.predict method gives us just a list of numbers. And right now, this is somewhat informative, but not that great. This 0 here means that the 0th entry is in cluster 0, and then this entry is in cluster 2, this entry is in cluster 1, and so forth. But really, it'd be a lot better to visualize this. So to do that, we're going to store our predictions in a NumPy array named yk-means. And now let's go ahead and make a plot. Fig x is equal to plt.sub plots, only one subplot, x.scatter. As before, we're going to do column 0, column 1, and now we're going to try to add in colors, and we're going to set the colors equal to yk-means. And what we can see is that the colors are the predictions, and it basically got it right. So yay. Now let's go and make this a little bit prettier by making the size of the dots equal to 50 and making the color map equal to Viridis. And now this looks just a little bit prettier. Okay, so we see that this works pretty well. Now let's take a look at how this works. The way this works is it identifies a center of each cluster. It puts a dot in the center of each cluster, and then you are in cluster 1 if you are closer to cluster 1 than any of the other center points. So this is kind of hard to say, but easy to visualize. So let's go ahead and plot the centers, and then I think this will make a lot of sense. So what we're going to do is we're going to say centers is equal to k-means dot cluster centers x dot scatter centers 0 centers 1 color equals black size equals 200 because these are going to be big. They're the center, so they're very important. And let's make them transparent so we can still see the points. All right, now let's look at our new figure. And what we can see is that there's a black dot in the center of each clusters, and you are going to be in the yellow cluster if you are close to this dot, and you're in the green cluster if you're close to this dot, and so forth and so forth. All right, so this worked really well, and this was on a toy data set that we made up. Let's try something that's a bit harder. Let's try to play with our penguins. Let's see how this works. You have my permission to stop typing. This is going to be a pre-written example where we're just going to do the exact same thing with our penguins. All right, so we have a data frame full of penguins. And we are going to plot the culmen length and culmen depth by species. And we can see that it does look like we should be able to kind of maybe split this up into 3 clusters, where we have the Adelaiser in blue, the Chinstraps are in orange, and the Gentoos are in green. So we look like we should be optimistic at this point, except for the fact that I've told you it's not going to work. Okay. So now let's do in X to be penguins. It's going to be a n by 2 array. And we're going to get rid of the NAs. And we're going to run our k-means cluster with the number of clusters equal to 3, called the fit method. And then let's try to plot the predictions. And what we can see is that this does not appear to be the same clusters as before. So it did not work very well. And the reason why it didn't work very well is that A, our clusters are kind of close to each other, so it's a little bit harder. And equally important is that the true shape of our clusters seem to be kind of long and elongated. And the k-means clustering algorithm is designed to work when the clusters are kind of round and circular. So the good news is that there are more sophisticated and better clustering algorithms, which we can use instead. We're not going to get into them in this class because this is meant to be an intro to Python class, but there are many other clustering algorithms out there, and some of them can be used to handle problems such as this. All right, that's it for this video. It's a brief introduction to clustering. I'll see you again next time.